In section 3, let's proceed by looking at characteristics of cloud computing. There are basically 5 characteristics that we'll be focusing on, and these are the most important. The first one is the on-demand self-service, and the next is the ubiquitous network access, and also then the location and transparent resource pooling, and then rapid elasticity, and finally the measured service with pay use. These are the definitive characteristics that might actually distinguish between cloud computing and probably just the web. These are also discussed in mail and grants, especially if you look at how these concepts have been applied by Jackson and Gosling in 2018. Right, let's start by looking at on-demand self-service. On-demand self-service is where a consumer can unilaterally provision computing capabilities as needed automatically without going to a service provider and requesting something like storage or computational power, CPU power, and so on. So a user doesn't need to approach the organization. If it's Amazon Cloud, AWS Cloud, you don't need to go to Amazon and say, oh, I need more storage, I need more memory or anything. As a consumer, you just you know provide, just specify what you need, and these are given to you automatically. So there's no other intermediate person between you and the cloud. So that's what we mean unilaterally provision computer resources as you need them. You simply write. So you may need more server time, you may need network storage. All you need is to simply save yourself on demand. It's on demand self-service. So this is a key characteristics of cloud computing because of its capability to automatically configure. You remember during the definition we discussed dynamic configuration as well as automatic provisioning. Those are what makes on-demand self-service possible. Second, let's look at broad and ubiquitous network access. This is a key aspect, of course. So the capabilities, all the cloud capabilities are available over the network, and the capabilities are accessible through standard mechanisms that promote use by heterogeneous thin and thick clients alike. So we don't have to make use of different protocols, different network protocols. uh, these are the standard mechanisms like the web, and also the addressing is probably it just follows the usual web addressing or internet addressing, HTTPS protocols. Right, examples of thin clients which are able to access cloud-based services are mobile phones, tablets, laptops, workstations, and these days there are more and more devices that are capable of accessing the network and therefore accessing the cloud services. Third, now let's look at the concept of resource pooling, because we in the definition, remember, we talked about shared pooled resources, right? So the provider's computing resources are pooled together to serve multiple customers. In other words, if you have RAM, the RAM is just pooled together. All the RAM is created into some kind of a pool, and that pool is used to serve customers. because customers can demand what they want, they take a portion, and then when they no longer need it, the portion is returned to the pool, and so on. And therefore, users can take and return as they as necessary, right? So there is this is achieved through a model called multi-tenant, the multi-tenant model. This is where different physical the multi-tenant model involves different physical and virtual resources, of course, that are pooled, and resources are dynamically assigned and reassigned. They are assigned when someone is done. If it's memory, they release it, and then that is reassigned as well. So the consumer, you normally just demand, and then there is dynamic assignment, reassignment of these, and that process can be automated. There is also a sense of location independent, in that the consumer generally has no control over or knowledge of the exact location of the provided resources. For instance, if you are using hard drive space, you wouldn't have an idea where you wouldn't even care where it could be stored, where it's located. It could be located in basically any country. It makes no change. There is a certain level of transparency. It doesn't matter where this memory is. It's what is important is that it's available to you. Sorry. But you may be able to specify the location at a very high level of abstraction. For instance, in Amazon, you can actually specify that you want your particular resources to be at a particular center. Mainly in the US, they've got quite a number of centers, and you can specify where you want your centers to be. But the Amazon has got a center, one center that is, for instance, rich in these resources. Probably this is where they start. They make sure that all the services are available at one of that main center, where almost every technology that Amazon provides, Amazon Cloud provides, is located at that particular center. And then as they build more centers, some of those resources may not be available at those centers. So if you locate your resource at that center, it will have to access the resources from other centers, which might actually affect your speed. So for efficiency, sometimes you may need to, at a very high level, specify the location of your service, of the services that you require. Right. So the concept of multi-tenancy is very important, and it's central to cloud computing. So there are two types of multi-tenancy. The first one is virtual multi-tenancy. This is where computing and storage resources are shared among multiple users. And also you have multiple tenants who are saved from virtual machines that execute concurrently on top of the same computing and storage resources. So that's a virtual multi-tenancy. There is also what is referred to organic multi-tenancy, where every component, in other words, hardware or software resources in the system architecture, are shared among multiple tenants, right? So those are the two major types of multi-tenancy. Now let's look at rapid elasticity. This is a very important concept in cloud computing, because it allows capabilities to be elastically provisioned and released, uh, in some cases automatically, to scale rapidly outward and inward, depending on the demand, right? In other words, elasticity is the ability for a resource to expand when demand requires it, and to shrink when demand also becomes lower. So to the consumer, the capabilities available for provision often appear to be unlimited and can be appropriated in any quantity at any time, because at any one moment each tenant uses only what they require, and if they don't require anything, they release it, which is now available to others to. So this release and assignment and reassignment supports rapid elasticity. So um, that's a central concept which enable cloud computing to happen. And finally, we look at measured service as an important characteristic. Cloud systems automatically control and optimize resource use, and therefore they do measure the usage of resources. And this is done by leveraging a metering capability at some level of abstraction appropriate for the type of service. In other words, if you are using the network, they measure how much bandwidth you are using at a unit time, how much data units are transmitted. If it's storage, they also measure how much are you storing, and so on and so on. So resource usage can be monitored, controlled, and reported, and that provides a high degree of transparency for both the provider and the consumer of the utilized cloud service, such that if you are charged per unit, it becomes very easy. It's transparent that you have used so much gigabytes, or if it's network, you have transmitted so much data per second, or so much data within a specified unit of time, and you can easily calculate how much it costs, as long as the provider has set the cost per particular unit. Right. These are the five characteristics of cloud computing, and between, they further distinguish between the cloud and the web. So that that allow you to basically, in fact, with the web, when you are charged even by a service provider, usually they charge per month, and there is very little monitoring going on or metering going on. Sometimes your application might require you to measure, to perform measurement, but the cloud can already does that. One of the major reasons why they do that is so that they can cost it, but you might have other reasons to measure efficiency of algorithms, how it's making use of memory, how it's making use of space. So you can actually use the cloud infrastructure to perform, because it does it anyway. So that's those are the five characteristics of cloud computing. With that, we conclude this section 3, and we will proceed next. We'll look at section